name is Arham, and welcome to my channel. In my channel, I post all educational videos. I understand all parents try to control our TV or YouTube time, and my parents are no different. I promise you will not regret watching my channel. And your parents won't be having any objection for watching us learn a new topic each week. You have noticed, all my videos have a test link in the description box, so you can test your knowledge after watching the video. Hi friends, I hope you're having a good day. Today we're gonna explore what makes an object sink and float. So let's get on to the video. I collected a few objects and let's see how it behaves. Let's start with the feather. Do you think it floats or do you think it sinks? It floats. Write in the comment section below if you got it right. Now let's try the metal spoon. Do you think it floats or sinks? Let's try it out. It sinks. Now let's see if the plastic spoon sinks. I think it'll sink because if the metal spoon did, then the plastic spoon would. Let's see if you got it right. It floats. I never thought it would float. Looks like its shape doesn't matter. Let's try this plastic piece. I'm sure that this would float because it's made out of plastic like the plastic spoon. Let's try out. Wait for it to sink. It sinks. Looks like material doesn't matter either. Then what matters? Let's try the stick. As expected from me, I never seen a stick sink. Now let's try this wooden block. I think it'll sink because, like all the other ones, let's find out. Oh, it floats! Shape doesn't matter, or material doesn't matter, then what matters? For something to float or sink. I should go back and read about what makes something float or sink. You want to come along and see what really matters? Okay, cool, then come. I got the idea why things float and sink. Have you heard about density? Density is what makes things float and sink. Let me explain. Woo! You know all objects are made out of small molecules tied together? If the molecules are really very closely tied together, that means the density of the object is high. For example, rocks, metal spoons, and coins. If the molecules in an object are loosely tied together, that means the object is less dense. For example, wooden stick, balloon, plastic spoon, and bottle. So if the object is more dense than water, it'll sink. On the other hand, if the object density is less dense than the water, it'll float. Let's see the chart of the high-dense objects and the less dense objects. Some high-dense objects are rocks, coins, metal spoons, and hard balls. Some low-dense objects are bottles, plastic spoons, wooden sticks, and balloons. Now we understand that objects with a high density sink and objects with a less density float. You must be wondering how big ships and cruises made up with high density metals get to float. Let's look at it further. Have you heard about buoyant force? Let's see what it is exactly. Buoyant force is the force on an object exerted by the surrounding fluid. When an object pushes water, the water pushes back as much force as it can. The force is basically called a buoyant force. That's why when you dive in water, you come back on top first. Because water pushes you back with the same force you dive with. If the water can push you back as hard as the object floats, else sinks. According to Archimedes' principle, buoyant force is equal to the weight of the fluid an object displays. Let's see an example of 1 ton of iron block and 4-ton iron boat. It might be possible that the water displaced by a 1 ton iron block by 1 ton of iron block is less than its weight. In that case, it's going to sink because the buoyant force is less than the weight of the iron block. Now let's make a 4-ton iron boat. You might have noticed that it is in an elongated shape, so it can displace more water than its weight. This time, it is a 4-ton iron boat. But the weight of the iron object spreads out, which helps it displace more water than its weight. The more water it displays, the more buoyant force it'll be. This time, the buoyant force is more than the weight of the 4-ton iron. Hence, it floats. In simple language, you basically need to design a 4-ton boat in such a way so that density can be less than water. If you need to calculate density is mass per volume. More the volume, the less will be the density of an object.